So hello everyone, welcome to the second lecture of this Generative Deep Learning series. So we are just going from learning the basics of the LLMs, how to make ChatGPT 4 and how to build the multimodals models. Okay, so we will just see this all the things. Okay, with the time. Of course, this is we are going to. I'm just explaining this whole book to you that what this thing is, and we are just doing it in a very interesting way. And if you haven't watched the first lecture, then just go in the description. There will be a link. You go to the playlist and you can access all from that there. Okay. So introduction to the generative deep learning. I hope we will see that what this thing is. So we have taken the highlighter. Okay, fine. So we will skip this part. And okay, so that is the chapter one, generative modeling. What is the generative modeling? What actually this thing is? So we are just going to learn this thing. Um, okay, so like just by seeing the name generative, generative is to generate. Okay, which generates. Modeling is it making the model. Okay, so what is the chapter goals? Chapter's goal is to understand about the generative and descriptive models, discriminative models. Okay, we will see all these things and understand the desirable properties of the generative models through a simple example. Okay, we'll see all these things and learn about core probabilistic concept underpin generative models. We will see these concepts and different families of generative models, clone the database that accompanies this book. Okay, so yesterday, okay, so in the previous video we had seen there is a GitHub link given. So I will also give this GitHub link in the description. You can just access in this book's code from there. Okay, this chapter is general introduction to the field of the generative modeling. So this is going to be the just a general introduction. We will just quickly we'll go through this chapter. Okay, because I don't really love much of theory. I just more focused on the practical part because practical is what you do, I do, and that makes us more understand the things. Okay, so we will start the general theoretical introduction. Okay, so what is the theoretical just see what is the theoretical. What is generative modeling? Generative modeling is a branch of machine learning that involves the training a model. So training a model to produce the new data given to a given set. Okay, कहने का मतलब means that it is a model. Okay, it is a model which generates the new data based on the given data set. Means just see this thing that you got training data. You got a training data of a horse. Okay, and then you got the generated sample. So this is quite different from the training data, and that is what the generative modeling is. Okay, so this is the generative modeling. Okay, so generative modeling is this, and training the model, and then it has generated the samples. That is a very simple thing. Okay, these all things are saying these things. Okay, we require a data set consisting of many examples. So this is training data that you have given the pictures of horses. So that is called the training data. These are the few terms. If you are not familiar, you just get familiar, I hope. And okay, and one such data point is called observation. Means one picture is called observation. Okay, that's the very simple thing. Okay. Each observation consists of many features. Okay, so if there is a picture of a horse, then there is very different features like eyes here, its nose is here, mouth is here, something like that. His ears are here. So these are the features. Features are simple that if I am human, like I am of course human, so these are my ears, nose, eyes. So that is the features in the picture. Okay, so a generative model must do probabilistic rather than deterministic because you want to able to sample many different variations of the output. So what it means we'll see in this text. So for an image generation problem, the features are usually the individual pixel values. For the text generation problem, the features individual words or group. Okay, so let's understand this thing. If there is an image generation, then it will be focused on each individual pixel value. What is the pixel? Pixel is the smallest value of an image. Just see what is the pixel. We are going to just do a hands-on learning. What is the pixel? Pixel of image means just see what is just see this thing. The smallest unit of a digital image captured by a camera. So the smallest unit of a digital image is called just a pixel. Okay, so it will be focusing on the pixel. Okay, wait. So it will be focusing on the pixel values. If we are going to see the text generation problem, text generation means something what the chat GPT do. So text generation problem, the features could be individual words or a group of letters. That is very simple thing. Everything is in the basis of a smallest thing. Like we had started learning the letters, then we started words and then making the sentences. So I'm speaking English, something like that. So that is the approach the scientists and the experts are taking to make an AI or a model. Okay. So it is our goal to build a model that generates new set of features that look as if created using the same rules as the original data. Okay. So these are the things conceptually for the image generation. This is an incredibly difficult task. Okay. So if we'll see conceptually, image generation is really a difficult task. Considering the vast number of ways the individual pixel values can be assigned. So there are very very small pixels are there. So it will be so much that it will be difficult task of image generation. But don't worry, my friend, we are going to do it in a easy way. Okay, because scientists before us are doing the work, researching, they have made it very easy to do it. If our model is merely a fixed calculation, so it's taking an average value of each pixel, training that is, it is not generative. Okay, so we will see this is we will prove this statement that why a generative model should be probabilistic, not deterministic. What deterministic means? It is like determine something. Okay, we'll see what the it will explain in a very simple way that what the discriminative and generative model means. Okay, in other words, we can okay, model must include random component. Okay. Just think that model should like if we want to generate new image, just think about it. Then we have to some differences from the original image. We don't want all like a, almost same pattern. We don't want, we want some noises in between so that it will get different images. Okay, we want different image, different type of image. Okay, so we want some random component. Okay, we want some random component that influences the individual samples generated by a model. Okay, I hope you got some idea that what the generative and discriminative model is. So in the other words, we can imagine that there is some unknown probabilistic distribution that why some images are likely to be the found in the training data set and others images are not. It has a job to build a model that mimic. So our job is to mimic the distribution as closely as possible, then sample it to generate new distinctive observations as look as the original dataset. We want something similar to the training dataset, but not exactly same. Okay, we want something different. Okay, just think if you have a model, you just give a input, picture input to a model, just generate picture something like it. Then it will generate the same image. Then what is the value of that model? Nothing. But if you give the image of cat, or you just write that give me cat image, then it will generate a new cat image. Okay, so we can do that. Okay, so just see how we can do that. Kriya dot. So this is the website. I will also give this website. And this website is quite interesting because you can um, just see the prompt is a dog in the garden. Okay, okay, we have to sign up or login. So let's see. We'll just put a new email, continue with email. We'll just put the password and sign up it. Okay, okay, okay. Wow. So here they have they have changed it actually. I really love this thing. Oh wow. I really like portrait. You can just get a portrait image of the dog and you can upscale it. So just see, just a cat in the garden. We will change just a cat in the garden. So here is the cat in the garden. We'll see different type of images. Just see in the CGI. See it has CGI picture. Just see in the carbon image. Okay, it is horrible, I think. Okay, portrait is better, I think. Okay, you can just see this thing. We can also do some. Oh, okay, just see. So we can generate the images that are different, and we want to generate different images. Just see this thing. Okay, just see. We want different images. So this is about the generative modeling. Okay. Um, in order to truly explain what the generative modeling aims to achieve, okay. So I will just one thing I will say that probabilistic means that generative model will do some probabilistic thing, not a deterministic thing. Deterministic is just a fixed thing that just give the input and you'll get output. But probabilistic is like you'll generate something new data. Okay, because we want to able to sample many different variations of the output. That is the very simple thing. Okay, I hope you got this thing. Then we will focus on the generative versus descriptive modeling or discriminative modeling. In order to truly understand what the generative modeling aims to achieve and why this is important, it is useful to compare it to its counterpart, generative modeling. Okay, fine. So, okay, what the discriminative model does, it actually discriminate the things. Means just we have given the pictures, many different pictures, and of a particular just in this book, in this context, there is a example that I'm taking example. Just see that I am just giving some image inputs of pictures of Leonardo da Vinci, and just say that Mona Lisa picture is there and there are different pictures. So it will flag the Mona Lisa picture and it will predict that okay, the prediction will be like okay, 90%, 90, 98, 99% that okay, this model is from the Leonardo da Vinci. But what if it is not the Leonardo da Vinci model? Then, Leonardo da Vinci picture. Then it will simply say that okay, uh, it is not. So it will be predict. It will discriminate between the pictures that okay, this is the uh, Leonardo da Vinci has painted this thing or not painted this thing. Very simple thing. So that is called the discriminative modeling. That and in the training data of discriminative modeling, you need to give that okay, this is the picture and this is going to be the tag that it is a picture of Vinci picture. Okay, I am saying that Leonardo da Vinci in a short form Vinci picture. Okay, so there you have to give a label. Okay, so this label and if generative modeling, in the case of generative modeling, you will generate, so you don't require the data set to be the labeled. You don't need, you just give the pictures of anything. Just we are taking the example of a cat. Then you will give the image of cat and and it will generate simply the image of cats. That's it. New image of cat. So generating entirely new images rather than trying to predict the label of a given image. Okay, so it will not predict the label that it is the Leonardo da Vinci picture or not. It will actually generate new images from the training data what we have given. So discriminative modeling is about y label is given here. Okay, y label is given here, and x is the observation and y is the label. But in the generative modeling estimates, the x is the data. That's it. X is the observation. We will just give the observation and we will get different type of observations. That is a very simple thing. Okay, and there is also conditional generative models, because we can also build generative model to the conditional probability. Okay, so like our data set contains different type of fruits, we can tell our generative model that this is the apple. So conditional generative models are also there, because of course there will be a different type of cats. Like white cat is there, then you have to label this, that okay, white cat is there. Then after you'll give prompt that I want the picture of white cat. Then it will generate that particular, we will take that particular data set and then generate the white cat, or maybe in the case of black cat, what you like. Okay, so rise of generative modeling. Until recently, discriminative model has been driving force behind most progress in machine learning. Okay, listen, discriminative model is very important. Okay, I will see why. Just, just, just understand this thing, that if a doctor, if a like we had made, like many researchers have made like X-ray identifier, or that they can the models can actually discriminate about that this X-ray, or this whatever the report is the cancer or not. So it is about discriminating that okay, this is the cancerous and this is not the cancerous, or like this has the brain tumor, the MRI scan has the brain tumor or not. So this was all about the discriminative. But now we are in the age of generative modeling, where generating the text, generating the different type of human text actually, or human like text and like pictures, or music videos. So this is about the generative AI. So we are in the age of generative AI, where we will be generating the pictures. Okay, so these are the different pictures. Okay, and we are getting more clearer pictures with time. I don't know why they have given this example. Like this is very vague example, I will say. Because in the 2014 they just see that there was so much noise, but the noise is getting less and the clarity is getting better in all the images. Just see this thing. Okay, this is exception, I will say. You can just see the image here. I will say a portrait. Okay, just see how realistic she is looking. Just see. So it is really interesting to see that how. Just see. So, and this is the actually fastest, one of the fastest model, I will say. Okay, fine. So, just a doctor may benefit from a model that predicts if a given retinal image show the sign of glaucoma, but not necessarily benefit from the model that can generate novel pictures of the back of an eye. Okay, so what a doctor need to predict that there is a glaucoma in the eye or not. So if a machine can do it, then that's good. So that is what the discriminative modeling do. So uh, that's why they were that discriminative modeling was very famous, and it's still the relevant. It's going to be uh, yeah, it is going to be there. Okay, but generative modeling has different aspect and different use cases. I hope for today is enough. In the next lecture, we will see the generative modeling and AI in more details, and we'll also see our first generative model, Hello World. Fine. So I hope you understand this thing. Anything you have any issue, anything you suggest, just write in the comment. Any question you have, just write in the comment. I will happy to help you. Thank you so much. And yeah, also subscribe this channel if you like it and like this video.